This is the second part of Euclid Book 3, proposition number 36. We have drawn the circle once again from A to B to C, all the way back over to A. Alright, we found the center of the circle, which is E. Now the difference between this part and the other part is that the line DA right here, this AD here, does not pass through the center of E. So our proof's going to have to be a little different. Alright, we do have DB here. Here's D, here's B. And as you can see here, this is once again a tangent line. Okay, it's going to only hit point B and that's it. It's not going to touch the circle at any other spot. And then we have AD, which cuts the circle, and it cuts the circle at point C. So we're going to have a line drawn from point E to point C. Alright, we're also going to draw a line from point E to point D, another line from point E to point B, and then we're going to make a line, and it's going to be called EF. EF here. F is going to bisect AC. Now, how is it going to bisect AC? Because we're going to make EF here perpendicular to AC. That's what we're going to do. Alright, all that's given to you. Now Euclid says, alright, first of all, angle EBD, well here's E, and here's B, and here's D, is 90 degrees. We can prove this by Euclid Book 3, proposition number 18. And then, of course, we can say that EF here bisects AC by Euclid Book 3, proposition number 3. We can then go on to say that the length of AF here is equal to the length of FC. Why? Because AC was bisected at F. We're also then going to add the length of AC. Well, here's AC here. We're going to add that length to length CD here. Okay. And then we're going to form a rectangle. Two sides of that rectangle are going to be the length of AD. Two sides of that rectangle are going to be the length of DC. Let me show you that rectangle. Here's the rectangle. Two sides of the rectangle are going to be the length of AD, which is right here. And two sides of the length of that rectangle are going to be DC, which is right here. Okay. Now, we are then going to form a square. And that square is going to be FC. Alright. Where's FC? Well, FC is right here. This is going to be the length of every side of that square. Let me show you the square of FC. As you can see here, we have the length of FC here, the length of FC here, the length of FC here, and the length of FC here. So, the rectangle formed by ADDC, this area right here, plus this area right here, is going to equal the area contained by square FD. Now, where's FD? Well, FD is right here, from F to D. So, if you were to form a square, and each side of that square was going to be the length of FD, then the area inside of it would equal the area inside of this plus this. Boom. Okay. The area inside of rectangle ADDC. Well, here's ADDC. Right there. There's the area right there. Plus the area contained by the square of FC. Well, where's FC? Well, here's FC here. And here's FC here. So there's the square of FC. We're going to add these two areas together. And then we're going to add the area contained by square of FE. Well, where's FE? Well, FE is right here. FE. We're going to form a square out of this. And we're going to add that area to this and this. And if we do, we will get the area of FD, which this is FD right here. And the area is going to be the square formed by FD. And then the area of FE. Well, this is FE right here. So the area contained by square FD and the area contained by square FE equals the area of the rectangle ADDC plus the area of FC plus the area of FE. Okay. Now, we know by Euclid Book 1, proposition number 47, that the area of EC, well, here's EC right here, EC right here. We're going to form a square out of this line right out of here. Okay? The area contained by the square of EC plus the area contained by the square of FC, here's FC right here. Okay? Now, whoa, almost lost my pen here. The area contained by the square of FC plus the area contained by the square of FE, these two areas right here, are going to be the same as the area contained by the square of EC right here. And that's by Euclid Book 1, proposition number 47. Alright. The square of ED. Well, where's ED? ED right here. We're to form a square using this line right here. If we were to form an area from DF, well, this is DF right here, forming a square out of that, and form a square out of FE, so this area here plus this area here would equal this area here, and we know this because of Euclid Book 1, proposition number 47. Therefore, the area contained by ADDC, ADDC right here, plus the area contained by EC. Well, where's EC? EC is right here. So this area here plus that rectangle equals the area contained by ED. Well, here's ED. ED right here. We're going to form a square out of a square out of it. Okay? Now we know that the length of EC and EB are exactly the same. Well, here's EC right here, and here's EB right here. They're exactly the same because all radii of a circle are equal. Therefore, the area contained by ADDC, there's ADDC right here. There's the area right there. Plus the area contained by EB. Well, we're going to form a square out of EB right here. It equals the area contained by the square of ED. Well, here's ED right here. We're going to form a square out of it. Alright. Now, because the area of EB, this is square EB, and the area contained by the square of BD, these two areas right here, if we were to form squares around them, and you can do this at your own leisure, you'll find that those two areas added together come up with the area of ED. Okay? This is by Euclid Book 1, proposition number 47. So therefore, the area contained by the rectangle ADDC, there's that one there, plus the area contained by the square EB, here's EB here, is equal to the area contained by EB right here, plus BD right here. These two areas here. This one here and this one here. If you were to subtract the area of EB from both sides of that equation, you'll find that the rectangle of ADDC, that one right there, is equal to the area of the square formed by BD right here. And that's what Euclid wanted you to prove. I will tell you more in a future video. Stay tuned.